I'm going to talk you through problems 5 and 6 now on the forces review problems with the coefficient of friction. And number 5, a block is pulled up a ramp as shown here. The coefficient of friction between the block and the ramp is 0.36. We want the acceleration of the block. We got to make sure we get all of our forces drawn properly. The normal force is going upward. The force of gravity perpendicular is going downwards. We're pulling to the right. There's a force of friction going to the left. And don't forget, gravity parallel also pulls to the left. So we're going to have 2 arrows in our left-right direction, or just in our left direction, and 1 on the right. So now our normal force is upward, gravity perpendicular is downward. It is not accelerating up and down. So I know that normal force equals gravity perpendicular. Just plugging into the equation on our equation sheet, the gravity perpendicular is the cosine of the angle, which is 35 degrees, times the mass, 15 kilograms, times g, which is 9.8 meters per second squared. And that tells me that my normal force is 120.4 newtons. Now we can go and figure out the acceleration of this thing. Our force to the right is the force of pull, which is why this is positive. And to the left, we have friction and gravity parallel, which is why they are both being subtracted here, friction and gravity parallel, both with minuses. I'm out of forces, so that means equals ma. My equation stays exactly the same, except where I had friction, I plug in what friction is, which is the coefficient times the normal force. Once I've done that, I'm going to do the little algebra to solve for the A. So I just divide the mass to the other side. And now I can plug in my numbers. The force of pull is 150 newtons. That was given in the problem. The coefficient is 0.36, also given in the problem. And we solved for the normal force, which was 120.4 newtons. Force of gravity parallel, we have the equation on our equation sheet for that. It's just the sine of the angle, 35 degrees, times the mass, 15 kilograms, times g, which is 9.8 meters per second squared. All of that's divided by the mass, which is 15 kilograms. Plug that into my calculator, and I get 1.49 meters per second squared for the acceleration of the block going up the hill. Now let's take a look at number 6. Number 6 is a multi-block problem. We have block A, which is 20 kilograms, sitting on a table. There's a cord attached to the block that extends horizontally to a pulley to another block hanging off of here. The coefficient of friction between block A and the table is 0.44. A 10 kilogram block hangs at the end of the cord. We're assuming the pulley to be massless and frictionless. That's the pulley, not the table. The table does have friction. We're trying to find A, the acceleration of blocks A and B, the tension in the cord. We've got to make sure we get all of our forces drawn properly. So the normal force is going upward on the block on the table, gravity is going downward for the block on the table, and friction goes to the left. There's also a force of tension pulling the block to the right. For the hanging block, tension goes upward and gravity pulls downward, and I put the masses that were given in the problem in each of the blocks. We know the coefficient is 0.44, and we're trying to find the acceleration and the tension. So I need to find what the normal force is so that I can find the force of friction so I can actually solve for the acceleration of this thing. Now the normal force is up, gravity is down. We know it's not accelerating up and down, so they're equal to each other. So normal equals gravity, which is mass, 20 kilograms, times 9.8 meters per second squared. So my normal force is 196 newtons. I'm now going to come up with an equation for each block. We have to do that separately in the direction of the acceleration. I'm saying if the system moves clockwise, so this block moves to the right and this block moves down, like I've drawn here, then that would be a positive thing. If the pulley goes counterclockwise, meaning this block would go up and this block goes left, those are negative forces. So for block A, the 20 kilogram block, tension goes to the right, that's a positive, and force of friction goes to the left, so that's a negative. That's why I have tension minus friction, and that's going to equal the mass of that block, only that block, times the acceleration. For block B, force of gravity, I know it's pulling downward, but that's going to make this pulley go in the clockwise direction, so force of gravity is positive. The tension is negative. And that's why we have force of gravity minus tension equals the mass times acceleration of that block and that block alone. We have a simultaneous equation. We're going to add these two up, and my tensions will cancel. There's a positive tension, there's a negative tension, and they will go away. That's going to leave me with force of gravity B. It's still positive because it was positive in the equation. Minus force of friction, it was minus in the equation, so it's still negative or minus down here. And that's going to equal the two masses times accelerations added together. We're solving for A, so we're just going to factor it out because we have it in two different spots, giving me A multiplied by the two masses added in parentheses. And where I had force of friction, I'm going to plug in the coefficient times the normal force because that's what friction is. Finishing up to solve for A, we're going to divide by those masses, which is why they are now in the denominator in our equation, and I can plug in my numbers. Force of gravity is 10, because that's the mass of the block, times 9.8 meters per second squared. The coefficient of friction, 0.44, and the normal force, we solve for it, it's 196 newtons. And in the denominator, we have 20 kilograms plus 10 kilograms, the masses of those two blocks added together, and that gives us an acceleration of 0.39 meters per second squared. We're trying to solve for the tension as well, so all I have to do is take my acceleration and plug it back into one of my equations that I had up here. I picked A just because it came first, no particular reason. So that was tension minus friction equals the mass times acceleration. Solving for tension, I just add friction over to the other side, and now I can plug in my numbers. My mass was 20 kilograms, acceleration we just solved for, 0.39 meters per second squared, and friction is the coefficient, 0.44, times the normal force, 196 newtons. And when I plug that into my calculator, I get 94.04 for my answer. There should be a newtons on there. I'll have to fix that. So the unit for this is newtons.